Hi, my name is William Schaeffer, and I would like to talk about global warming. This is not a political talk, but just a review of some of the processes involved. First, for every gallon of gasoline that is burned, 19.2 pounds of carbon dioxide are put into the atmosphere. A gallon of gasoline weighs about 6.7 pounds. It is largely a string of carbon atoms with a few hydrogen atoms. During combustion, over 12 pounds of oxygen are removed from the atmosphere. It's combined with the carbon in the gasoline and reintroduced into the atmosphere as exhaust. So when 1 gallon of gasoline is burned, 19.2 pounds of carbon dioxide are put into the atmosphere, and it largely stays there. Some carbon dioxide is removed from the forests and plants, and some carbon dioxide is removed into the ocean. But over time, the process of combustion of fossil fuels has put a measurable amount of carbon dioxide into the atmosphere. Between the years 1957 and 1975, the carbon dioxide of the atmosphere of the planet Earth increased a measurable 5%. Now a bit of history. Planet Earth is 4.5 billion years old. The oceans first appeared about 1 billion years ago, and it is not entirely certain where the water came from. Nevertheless, about 700 million years ago, the first signs of life started to appear in the oceans. These were simple animals and plankton, one-celled plants. Now the plankton took carbon dioxide out of the atmosphere, and it used the carbon to build the cell walls, to build the fiber that distinguishes the plant from the animal. And over time, plankton would die and fall to the bottom of the ocean. And over hundreds of millions of years, literally, this removed carbon dioxide from the atmosphere. About 200 million years ago, land plants first started appearing. And similar to the ocean plants, they removed carbon dioxide from the atmosphere and used the carbon to build their cell walls. And when they died, they fell into the earth and buried the carbon in the earth. And the land plants, over time, became coal. And the one-cell plankton became oil. Over time, the climate and the composition of the atmosphere has changed considerably. The atmosphere is largely nitrogen, oxygen, and some carbon dioxide. The amount of carbon dioxide is related to the amount of oxygen, and the oxygen content has varied from 18% to as much as 35%. Presently, we have about 21% oxygen in the atmosphere. During the ice ages, it was about 23%, and that could be why some of the ice age animals were larger. When it was over 30%, that's when we had the giant insects in primeval Earth. The climate of the Earth has changed dramatically from being, on one hand, an entirely frozen over ball of ice to the tropical hothouse we're familiar with from most dinosaur stories. So let's review a little bit. Plant life first started appearing about 700 million years ago. Plant life removes carbon dioxide from the atmosphere uses the carbon to build its structure, and then exhales oxygen back into the atmosphere. Over time, this process has removed carbon from the atmosphere and buried it in the earth, where it's turned into coal and oil. Now, about 150 years ago, humans discovered the internal combustion engine and petroleum and the process of refining petroleum into gasoline. As we've discussed earlier, when you burn 1 gallon of gasoline, it puts 19.2 pounds of carbon dioxide into the atmosphere. Over time, the amount of carbon dioxide is measurable, and it is determined to be due to human activity. In fact, from 1957 to 1975, the amount of carbon dioxide in the atmosphere increased by 5%. Over the course of modern technology, it's increased more, and it's measurable, and it's due to human activity. Now, most people believe that the Earth's mean temperature is connected or influenced by the amount of carbon dioxide in the atmosphere. When there was more carbon dioxide in the atmosphere, the Earth had a primordial, hothouse, tropical environment. There were no polar ice caps. As the carbon dioxide in the atmosphere increases, the temperature of the planet, the mean temperature of the planet, will increase. Now, gasoline isn't going away. There are no alternative energy sources. Gasoline represents the most compact, most efficient source of energy in the universe. It would take 40 acres of biomass to make 1 gallon of gasoline. Alternative fuels are not practical. We're still going to burn gasoline and coal and oil until we find another energy source, which we may not find. And as long as those are available, we are going to use them. People will not use them. And the carbon that's buried in the earth will continue to be put into the atmosphere, and it will largely stay there. This will result in an eventual rise in the mean temperature of the planet of 9 degrees, or maybe as much as 15 degrees Fahrenheit. Now, there's other factors that affect the temperature of the planet. We're not going to go into all of those here. Right? And the greenhouse effect is correlated to the amount of carbon dioxide, and that is a steady effect on the mean temperature of the planet. If everything else remains the same and the carbon dioxide increases in the atmosphere, then the mean temperature of the planet will raise and we will have global warming. Now, one effect of this global warming will be all the glacial ice will melt. And a friend had said before that, well, if you have ice cubes in a glass of water and the ice melts, the level of the water doesn't change. And that's true, but all this ice is on land, and when it melts, it will run down into the water. And the surface of the ocean, the sea level, has changed dramatically over time. 20,000 years ago, the sea level was 300 feet lower than it is today. And it had been at that level for more than 2 million years during the last ice age. In primordial times, when the Earth was a tropical hothouse, the oceans were 300 foot higher than they are today, and there was no polar ice. In the history of the Earth, climate has been a succession of steady state conditions that persisted for a while, and then it changed to another steady state condition. We've been living in a temporary steady state condition for the last 15,000 years. Now, as we continue to burn fossil fuels and the mean temperature of the planet raises, all the polar ice caps and all the glaciers will melt. And this will result in the oceans raising 375 feet. And the calculation is very simple. You can do it yourself. The land mass of Antarctica takes up 5% of the surface area of the planet. The ice on Antarctica is between half a mile and 1.5 miles thick. For the sake of ease of calculation, we'll assume that it's uniformly 1 mile thick. The oceans take 70% of the surface area of the planet. So the equation becomes 0.05 times 1 mile equals 0.7 times x, where x is the amount of sea level rising. There's a lot of generalizations and simplifications in this equation, but it still leads to a result that's plausible, and it will be about 375 feet. Now, how long will this take place in? It's hard to say. We are already starting to see the effects. By the end of this century, we will see the sea level rise by maybe a foot, maybe 200 years to 1,000 years before these effects are totally irreversible and very, very obvious. But this is the future. This is what will happen if we continue to use fossil fuels, and we will continue to use fossil fuels. This idea was first put forth in 1880s, and it was shown to be true in the 1930s. But the basic facts are this. If you burn 1 gallon of gasoline, it puts 19.2 pounds of carbon in the atmosphere. There is no energy source that is as good, as compact, and as efficient and inexpensive as gasoline. We will continue to use coal and oil and gasoline until they are gone. And in the process, we will replace all the carbon into the atmosphere that was removed in primordial times. This will result in the planet mean temperature of raising up to 9 degrees. All the ice will melt. That is the scenario for global warming, and those are the factors that are influencing the outcome. I appreciate you listening. Feel free to leave comments below, and have a great day. Thank you.